Okay. Hello, this is TA Eunbyeol. Please make sure to download all the materials, including source code, and source code means this file, and two Python files from Classroom. Okay. Today, we will cover GAN with PyTorch. The main points of today's practice are understanding 그거는 아니고, 네. 이 코드 파일이랑 두 개 파이썬 파일만 가져가시면 됩니다. 네. Okay, the main points of today's practice are understanding basic concepts of GAN and implementing vanilla GAN. Also, we will implement noise sampling and GAN loss to train the GAN. I hope you remember the GAN lecture from this Tuesday, because today's exercise haven't relied on that knowledge. I should mute everyone. Okay. First, check your GPU setup. And first import some packages. I think these packages are familiar. Can you hear my voice? Yeah, I think Taewon can check. Yeah. Please check. Okay. And this code just creates some folders which we will use later. Yeah. OS make directory. And second preliminary step is hello, I cannot open the file with Core. Are we supposed to use other platform instead? Cecilia, I think, did you open the IPYNB this file on your Core? Okay. Yeah, Cedric is right. Just open the notebook. And second preliminary step is to define the visualization and saving codes. I will not explain in depth about this code because it's just about the matplot library. You can find how to use this on Google. And the third preliminary step is to load dataset and define the data loader. We will use MNIST again, which is very familiar to us. As you know, it's a comparatively smaller dataset than others, but you can also use Cypher10 or any other larger dataset if you're interested in. Okay, just run this code. Now let's delve into today's main topic. This is the first part of your practice session. Here, our primary task is to define both the generator and discriminator. Please implement discriminator and generator using MLP layers because we haven't covered the CNN yet. So just use MLP multi-layer perceptron layers. Understanding the inner working of both the discriminator and generator will be crucial to completing this task. Specifically, you should be clear about the inputs and outputs for each component. For generator, the input is random noise. and output should be the generated image, and for discriminator, the input should be the image and output should be some logics, right? Now I'll give you 10 minutes. Please implement your own generator and discriminator module. After 10 minutes, we'll go over answer together. Let's get started. Questions from Yongjae. Can we choose activation function of our choice? Yeah, you can choose your own activation function, but at the final layer, maybe you should consider the activation function. Yeah. Okay. Time's up. In my case, I think I can copy and paste. In my case, I build the generator like this. And for the function, like this. And let me explain. The generator input is the noise, right? So if the noise shape is 100 dimension, the first dimension should be 100. And you can use ReLU, leaky ReLU, or sigmoid, whatever, tonnage, but you should use nn.sigmoid at the final layer, since our generated image should be range from 0 to 1, right? And also, yeah, the last dimension should be 784, because we use MNIST. Yeah, I think you can do that. And how about discriminator? I made the discriminator use leaky ReLU, but it doesn't matter. But at the final layer, we should use sigmoid, since we will gonna use binary cross entropy loss. So the logic should be range from 0 to 1. So yeah. And how about forward function? When the input is given, we flatten the input to 784, and for the discriminator, yeah, and get the logit, right? Now let's move on. Okay. We need to load the model on the GPU like this, and define the optimizer for discriminator and generator, okay, which are optimizer D and optimizer G. How about noise sampling? Is the specific reason you add extra hidden layer? No. You don't have to add this layer. It just customized. You can just build your own generator or discriminator. Yeah. Okay. Your next task is to implement the noise sampling function. You can use torch.rend, which samples values from a normal distribution. Ensure that the noise size is set to batch size and noise dimension. What would be the answer? Can you show me one more time generator? Torch.rend and 100. Yeah, that's good, but we should consider the batch size. Okay, so maybe, yeah, Cecilia, right? Yeah, great. using grade, yeah. We don't need to put leaky ReLU. It's just your choice. You can use ReLU 10H, okay? And yeah, the answer is right, torch that. Okay. Why are the outputs of generator and discriminator in the range 0 to 1? For generator, we always use sigmoid at the final layer when the autoencoder and variation autoencoder, since the MNIST image is ranged from 0 to 1. The generator should generate the MNIST image, right? So for generator, it should be output should be range 0 to 1. And discriminator, I already mentioned, but we're going to use binary cross entropy. The logic should be 0 to 1 when using the binary cross entropy. Okay, Ujong, is it okay? Okay. Now let's delve into the training section. We'll train GAN using the pseudocode outlined Goodfellow's paper, which is a GAN paper. As most of you are aware, the discriminator and generator have conflicting goals. The discriminator aims to accurately classify between real and generated samples, while the generator's goal is to confuse the discriminator. Put another way, the discriminator seeks to maximize the objective function, whereas the generator looks to minimize it, right? However, based on our discussion from last Tuesday class, we'll make a slight adjustment to the generator's objective to ensure the stability during training, which means we do not minimize the objective function, but instead maximize the error, right? I mean this page. I hope you remember. Yeah. So okay. So instead of striving to minimize the likelihood of the discriminator being right, now we're gonna try maximize the likelihood the discriminator making errors. These approaches offer the same goal of fooling the discriminator, but provides a stronger gradient signal for poorly generated samples, which has become the standard in practice applications. With that context, your task is to implement the stock code in the subsequent code block. For simplicity, you can set k equals 1, where k is here. I'll give you 10 minutes to work on this, after which we'll walk through this solution together. And if any part is unclear or you have questions, please don't hesitate to ask, okay? Let's get started. I'll give you 10 minutes. Questions from Jongwon. Why do we change input size as instead of indiscriminator? Why do we in this case? You mean here? Ah. Mm. Yeah, you're right. Are we sure? The output is just logic, right? If we don't squeeze here, it just batch size comma 1, right? But when we calculating loss, it doesn't need this channel. Yeah, it's useless. We can squeeze. This channel doesn't used when calculating loss. Okay. Good. Question from Suji. Is there any specific reason to give noise dimension 100? No, it's just hyperparameter. You can use any dimension. Okay. Okay, time's up. Fixed noise is just copy and paste this part, right? We use fixed noise just save the image while training. It's not that important. And we'll use BCA loss and set epochs as 200. And since we defined two optimizer, D optimizer and G optimizer, right? Here, optimizer D is just for update network D, which is discriminator, and optimizer G is to update network net G, which is generator. So in this part, we're gonna update D network first, and then update G network, as illustrated like this. Okay. For simplicity, we've chosen K equals 1, but recall that a higher value like K equals 10 might be more appropriate. In such scenarios, you train the discriminator 10 times and then update the generator only once, right? But in our case, K equals 1, so. Okay. First, we need to clear the network D gradients, right? And move data to CUDA, a GPU. And what would be the answer for label? It is if, yeah, 1 is right. But you should consider the dimension. Yeah, Sangyun is great, yeah. Why did you sample noise prior to 3점 트링겐? Can you explain more, Taewon? Yeah. And how about output? Output should be since we're gonna make fake image, right? When making fake image, we should we should forward random noise to generator to make fake image. So we need to sample noise. Is it okay? Okay. And how about output? Can you guess what should be answer? Yeah. Yeah, great. Great. Okay. So I just copy and paste the answer. Here, right? So label should be 1 and output should be the loaded. And error should be, output label, criterion output label to maximize this cross entropy, right? And this part is just for printing function, just for print, not that matter. And we also trained discriminator with fake. In this case, as Taiwan asked, we should sample the noise and forward noise into network G to make fake generated image. And label should be zeros, right? Oh, 0. Yeah, this is 1 and this is 0. And you should also consider the batch size, and output should be the same. Yeah. And error fake, calculate error fake like this. And we can calculate the error for discriminator and backward and step. Okay. This is part for updating network discriminator. And then, before that, we make clear to just update network D. And it means fake is the output of network G, but in this part, this is fixed, but in this section, this noise is change for every iteration, but this noise is fixed just for saving figures for visualization. But yeah, you should use different noise when iteration. Okay. What I want to say is we detach the fake to make sure the just update the network D, not network G. We're gonna update network G here, right? In this case, label is important. What should be the answer for label? Yeah. You understand really well. It should be 1, not 0, because this is for generator. So this should be 1, torch.1 batch size. I will copy and paste this part. Great. Okay. So this part is to maximize log DGG, right? Just implement this equation. It just makes sure the only update the discriminator D, not G. Since this fake is the output of network G, there is computation graph. Yeah. Okay. And update like this, error, backward, and optimizer G step. And iteratively train this loop. Yeah. I hope you make this part clear. Okay. Actually, this part should take time long. What makes error? All tensor should be same device. I think. It took time quite long, so let's move on. Just visualization part. When you train this model, you're gonna see the loss somehow decrease to some extent, and you can visualize the generated samples like this. We define some visualization function plot GIF at the beginning of our practice session. By running this code, you can observe training process. You'll see that at the beginning of the training, the generated data looks unclear and maybe resembles some Gaussian noise. But as training advances, you'll notice the generated data image looks image converging towards the authentic handwritten digits, right? This looks like 7631111. I think there are too many one, but yeah. So in this way, you can qualitatively check the code to see if it's working well. Okay. It's training. And as you know, evaluating the performance of generative model is challenging. Unlike classification task, where the correctness of a result can be directly measured against a label, determining the quality of images produced by a generative model isn't straightforward. Various metrics have been proposed to address this challenge, but today we'll focus on thread chat inception distance, which called FI score. Are there many ones? Because it's easier to full discriminate. Yeah, I guess. I think, yeah. But we don't know the answer, but I guess, yeah. You're right. Okay, so FID score assess the distance between real and generated image samples, utilizing the feature space of the inception network, which is trained on ImageNet. In essence, features are extracted from both real and generated images, allowing us to determine the mean and covariance for each dataset. So the FID score calculates the distance between these feature distributions, and the results are aligned well with the human perception, right? Do you remember the class? Okay. I recommend looking into a relevant article or paper if you're interested in. Today, we're gonna leverage an existing FID implementation, which is available on GitHub. It's worth knowing that since Inception Network was trained on ImageNet, using it to compute the FID score for dataset like MNIST might produce results that aren't fully representative, okay? you can check this code. This code calculate the feature space distance using the mean and covariance for each feature. Yeah. Okay. Training is done. No. You can just run this code and you can check this FID score, mean and standard deviation from the real and generated samples and calculate the French distance. Yeah. These two files are our Python file, right? And you can just import this function. Yeah. When training is done, you can run this part. And the last part of practice session is DCGAN. I've already written down the code, the DCGAN. It just update the generator and discriminator. It use CNN. So I think there are two reasons. The first one is because it's easy to make one, and the second is history. Yeah. I agree with you. Yeah. I think one is easy to generate. Anyway, if you're interested in read this DCGAN paper and try to implement it yourself. Okay. Oh, yeah, great. Wow, there are too many one, right? Thank you for sharing. I think that's all for today's session. Do you have any questions so far? Why did you modify? Sorry. 재상, where did I change the code? Oh, I just prepare this. It's same. Cedric. Oh, yeah, training again is kind of difficult. Maybe you can increase K or upgrade your generator. Since discriminator works too well, you should increase the performance of generator. 크다. Okay, thank you. Thank you, Theo. Yeah. Okay, do you have any final questions? Okay. Thank you for attending today's practice session. Next week, new TA will come and give you a great practice session. Okay. I'll see you on December. Maybe, yeah, okay. If you have, okay, bye-bye. But you can leave except for Aldo. My shape are weird. Thank you. Aldo, can you share more detail? What is weird? Okay, 우정. The fixed noise is for fixing the generated image. Yeah, we can just compare the image. 그러니까 그 이터레이션 돌면서 생성된 이미지를 직접적으로 비교할 수 있으니까 뭐 첫 번째 이터레이션 때 만들어진 이미지, 두 번째 때 만들어진 이미지, 결국에 같은 노이즈에서 제너레이터만 업데이트된 제너레이터를 통과해서 만들어진 이미지를 비교하는 거다 보니까 좀 더 정성적으로 보기 쉬울 것 같아서 네, 한 겁니다. They are batch size types 700. Wait, Aldo. I'm sorry, wait, Aldo. 민태님 무슨 에러가 있죠? 그렇네요. 민태님, 컴마가 뒤에 다 있습니다. 그거 지우셔야 될 것 같은데. 네트워크 G를 업데이트할 때 레이블을 1로 두시는 이유. 이거는, 그러니까 네트워크 G랑 네트워크 D랑 지금 하려고 하는 G 달라가지고, 얘는 속여야 되니까, 그러니까 더 풀을 해야 되니까 레이블을 지금 1로 주면서 그쪽 방향으로 학습을 시키게 한 겁니다. 그 수식적으로 이해를 하셔야 되는데, 사실 이게 지금 한번 수식을 다시 보시겠어요? 그러니까 maximize, 그러니까 이거를 맥시마이징 하는 방향이 네, 레이블을 1로 둬야 이거를 맥시마이징 할 수 있고. Arlo, are you here? Can you share your code? Can you capture your code? Why batch sizes? I can get what is they? They are batch size times 7, 8. Although I can share the solution code, you can check what is the problem by yourself, or you can, okay. You did you get the plot from here? Plot GIF, Aldo? Oh, it is weird. It's really weird. Can you print the fake shape and output shape? It seems like you're printing your numbers as well. Mm-hmm. Oh yeah, maybe. You're right. Wait a minute. I start and here. Can you check shape here? I got runtime error. Bet1 and bet2 shape cannot be multiplied. Yeah, I think the problem 데이터의 쉐입이랑 네트워크 D를 저한테 공유해 주시겠어요, 수현님? I had the same error, but reshape. Aldo may be answer to Suyeon, right? Can you try this suggestion? Yeah. Can you try to suggestion from Aldo, Suyeon? Yeah, Jongwon, I can explain. It just for visualization, for every iteration. When you trained the generator, you should defer the noise, but when just for visualization, we can fix the noise. I think you will get the same weird shape as me. What? Can you show network D, Ardo? Just copy and paste. Or capture the, network D. 정원님 답은 되셨나요? 오케이. 네, 맞습니다. 그 외 용도는 없습니다. 네. R도, input shape should be weird because did you make sure input is batch comma 784? Can you 그 수연님도 그렇고 한번 이 forward 펑션을 이걸로 바꿔보시겠어요? Arthur, can you change forward function like this? Okay. Then, yeah, share the output. 수연님도 이걸로 한번 해보시겠어요? 네네, 맞습니다. 태호님, 저도 지금 그렇게 보고 있는데, 결과를 한번 봐야 될 것 같네요. Yeah. Uh, did you solve the problem? 그러니까, is it okay now? 질문 없으신 분들은 나가셔도 됩니다. You can leave if you don't have any questions. Okay, I wait. Same. Weird shape. Really? I don't get it. And okay, for the last time, can you share the generator part? I'll check. 폴더 내에 인셉션 파이가 있는데 임포트 인셉션 하면 에러가 납니다. 혹시 그 디렉토리 구조를 어떻게 하셨나요? 그러니까 그 inception.py랑 그 fidscore.py랑 이 주피터 노트북이 같은 선상에 있어야 돼요. 그 위치가. 제가 주신 폴더 디렉토리 내에서 그대로 사용하면 사실 임포트가 되거든요. 오케이. 한번 해보시겠어요? PIP 인스톨로 설치하는 건 아닙니다. 렐로. 아, I see. Although the first layer should be the noise dimension. Can you show my mouse point? The input of the generator is noise, not that image size. 잠시만요. 저 같은 경우에는 수진님, you just made noise image size. Okay, then I will read again. Then you make noise. Okay, great. Since we make noise dimension 100, if you should change, you should also change the noise dimension here. Here, wait. Here, and also here, right? But 일단 수진님을 먼저 보면은 저 같은 경우에는 디렉토리가 지금 이런 상황이고 여기서 이거를 하면 너무 많은데 한번 이렇게 해서 한번 보시겠어요? 저한테 공유해 주시겠어요? 만약에 잘 안 된다고 하시면 이 두 가지 명령어를 쳐주시겠어요? 저 같은 경우에 이 PR4AI 폴더가 지금 제 디렉토리이고 이 디렉토리에 지금 이 FID 스코어랑 inception.py가 있어가지고 임포트가 가능하거든요. import inception. 네? 콜앱을 쓰고 있어서 그럼 디렉토리를 조금 더 확실하게 할 필요가 있거든요. 지금 태원님께서 말씀하시는 것처럼 해야 될 것 같아요. 네네, 맞습니다. 맞아요. 아마 그 콜앱에서도 그 왼쪽이 잘 보시면은 그 폴더를 추가하는 게 쉽게 되거든요. 네네. 네, 감사합니다. 네, 맞습니다. 픽스드 노이즈도 네트워크 G가 지금 쿠다의 상태에 있기 때문에 포워드를 시키기 위해서는 픽스드 노이즈도 쿠다로 보내줘야 됩니다. Can you show train with fake code? Train with fake. Okay. You mean here, right? Yeah, thank you, Cedric. I think we can wrap up, right? For the last time, Ardo, are you okay? Okay. I hope. Oh. I'm not sure why this. Oh. Can you show error one more time? Oh, it's definitely your input size is back 128. Right? I think you forward the noise with dimension 100. Somewhere there are 100 and somewhere, yeah. This error means your input is 100 dimension, but in your code, the input shape is 784. There are clearly mistakes in your code. I hope you can fix. I will upload the solution file. You can check. I mean, I changed from 700. Yeah, but and if you change from 784 to 100, then everywhere you should change 100. But somewhere noise or generator, your model expect input to be shape 784. I'm sure there was mistake in your code. If you changed it 100, right? Then here for the function should be, yeah, okay, yeah. Did you find your mistake? Okay. Just make sure here should be 100. Okay. Can you go back there? Where? Update to G network. Okay. Update G. Huh. What line? 아, 다행입니다. 감사합니다. Error G.backward. Did you detach this part? And did you write this 0 grad? Oh, okay. Cool. Okay. Thank you all. Yeah. Have a good day. Bye bye.